Okay, let's get into this. BlindSight.
Right. It's a really striking phenomenon.
Yeah, I mean, imagine being clinically blind, right? Because the main visual part of your brain, V1, is damaged.
The primary visual cortex, yeah. No conscious sight.
But then you can still somehow react to things you supposedly can't see, like point to an object.
Or navigate around something in your path. It's counterintuitive, to say the least.
Definitely. It's a real puzzle in neuroscience. How does that even work? Reacting to vision without seeing. So that's what this deep dive is all about. We've looked at sources covering the, let's say, standard explanations.
The traditional neuroscience view, yes.
But also this, well, pretty radical new theory, motion theory. It really flips the script on how we think about vision.
It does. Big time.
So our goal here is to quickly get you up to speed. What BlindSight is, the usual explanation, why that might not be the whole story.
And then what this motion theory brings to the table, a completely different angle.
Exactly. Prepare to maybe rethink how sight works.
Well, the traditional view, which you find in a lot of the literature, often points to alternative brain pathways, sort of like neurological detours.
Detours, like when the main road, V1, is closed.
Precisely. The idea is that other, maybe older pathways can still process some visual information. Things like the superior colliculus come up a lot.
Okay, and what do those pathways handle?
Usually more basic stuff. Location, movement, maybe very simple shapes. But crucially, this processing happens, well, below the radar.
Below conscious awareness.
Yeah. So the brain and body are reacting, the systems are working, but it doesn't create that conscious picture for the person.
So they might feel like they're just guessing where something is.
Exactly that. But their guesses are often surprisingly accurate, much better than chance.
Right, and that's where the standard model, the one based on light particles, photons, hitting the eye, it gets a bit tricky, doesn't it?
It does raise questions. If vision is just about those light signals getting turned into electrical signals and reaching the right conscious spot like V1,
then how do these patients react so well when V1 is out of action? It feels like something's missing from that photon model.
or at least it suggests it's not the complete picture. Which leads us to ask, what if vision isn't fundamentally about passively receiving light particles?
Okay, so what's the alternative then?
This is where motion theory comes in. The sources introducing it propose something quite different. It suggests the eye and brain are actively synchronizing with the environment.
Synchronizing, like tuning into something.
Kind of, yeah. Synchronizing with what the theory calls structured rhythmic motion out in the world. So light isn't just independent particles hitting us.
It's more like patterns, rhythms.
Yeah, exactly.
Okay.
Organized rhythmic patterns.
Yeah.
And the visual system tries to resonate with them, to lock on. Think less like a camera just recording.
And more like finding a radio station or feeling the beat in music.
That's a great analogy. The brain is actively trying to align itself with these external patterns.
Okay, so how does that explain BlindSight?
Well, under motion theory, conscious vision needs certain complex synchronization loops to be active. Maybe the ones that heavily involve V1.
Right. So damage V1 and you disrupt those specific loops. You lose the conscious tuning.
That's the idea. But crucially, the theory suggests other synchronization pathways might still be working. Simpler ones, perhaps.
Ah, so the body and brain can still subconsciously align with those environmental rhythms, even without V1 fully online.
Precisely. They're still picking up and synchronizing with the structure, the motion out there. That allows for the accurate responses, even without the conscious feeling of seeing.
They're still, in a way, in sync with the visual world, just not consciously.
Exactly. And the sources take this even further. Motion theory ties this directly to consciousness itself.
How so?
It suggests that conscious perception emerges from this complex rhythmic synchronization. When the external patterns and our internal neural rhythms align just right, that's consciousness.
Wow. So BlindSight isn't just a weird edge case.
No, it becomes really powerful evidence. It shows vision isn't monolithic. It's layered synchronization. Conscious sight is one layer, but subconscious resonance can still guide action.
Okay, so the big shift here. It's moving from vision as passive reception of light particles
to vision as active resonance, a sort of rhythmic dance between the brain and the world's structured motion.
And BlindSight is key because it shows the synchronization can happen even when the conscious awareness layer is damaged. The photon model might just be incomplete.
It really reframes everything. So it suggests a much more dynamic, rhythmic connection between us and the world.
So here's something to think about. Building on that idea of consciousness coming from synchronization. If conscious awareness needs specific loose engaged, what other kinds of seeing or perceiving might be happening subconsciously? What rhythms are your brain potentially aligning with right now outside your awareness, just because those particular conscious loops aren't, tuned in?
What else are we resonating with without realizing? It's a fascinating question.